Okay, mathematicians, last one for area. I promise. You're doing so well. Stick with me here. So now we have trapezoids. And since your eyes are probably getting so good at analyzing these shapes, you might have noticed a similarity in how we can visualize and imagine and cut up these shapes to revert back to our original thinking of the area for a parallelogram is base times height. Now, with the trapezoid, though, we have a couple different things to think about. We have these extra pieces coming off, which kind of look like triangles. And then, but there's another one. So, really, we could have that one come over here, maybe, kind of like we did with the parallelograms, and that comes over there. So, we know we can't just use the numbers we have because the boxes, again, they're not full. So what if, let's try this. What if, let's take our pencil and let's mark a height line, just like we've been doing. We need these perfect boxes, right? And we know that makes a 90-degree angle, and that's our height line. And what if we take and we think about this triangle then that's been chopped and bringing it over here, right? So this base would then become part of this base, okay? And so then it would complete and make it into a parallelogram. Here's, I'll show you what I'm imagining. I'm imagining this triangle coming over here. Now it's not totally going to fit on my grid, but do you see how if we flipped it over there, it'd be a parallelogram, right? And so what we can do is, and I'm going to erase my imagination lines here, is we can use the base still, but there's not just one. So let's mark this one. This is one of the bases, and this is the top one, in this case, can be the second base. It really doesn't matter which one's the first one and which one's the second one, but you do have two different ones. So when we do this, we need to think about both of them. And I really like the back of the paper that we're going to look at here in a minute that shows how this kind of all comes together. What we are going to do is we are going to take, let's actually use our numbers then too, is 1, 2, 3, 4 is our height, right? And this base is 1, 2, 3. And this base is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are going to use the formula. It's a doozy. Area equals half times height, because they both will have the same height, right? This all of this has only one. And in parentheses, we are going to add base 1. See how it's not an exponent, it's down below. Plus base 2. I know. Interesting. There's more. Let's calculate that, and then we'll see it in action in more trapezoids and how we can think about this in different ways. So we know we're going to have the half still. The height was 4. And then one of the bases was 9, and one of them was 3. So I have to do order of operations, parentheses first, and I'm going to get 12. When the height is outside the parentheses, what operation is that? It's times. So I'm bringing down everything I haven't done yet. Now it's just multiplication, so this is back to a triangle, right? So we have that type of situation where I can do half of whatever these. So I'm not going to make my life harder and multiply the 12 times 4. I'm going to get that smaller to do a smaller number times 12 and then get 24. Okay, so this shows how important it was that we did our expressions and using the order of operations. So let's analyze first the heights and bases of different types of looking trapezoids and how they might show it in different ways. So one other thing to think about is, and I'll show a line here with my pen, is that every single trapezoid is also two triangles. It's just they're not going to be the exact same. And that's why you have to have those two different bases, right? So I could have cut that one there to show two different triangles. I can cut that one there. So really this formula works because you have technically two triangles. Some people will look at this in even a more, I think, a challenging way. So if I have, I'll just do a rough sketch of a trapezoid. Some people will go, no, 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 no. You don't have two triangles. You have a triangle, and a rectangle. And I'm going to find this one and this one and this one and add it all up. Well, that works too. But you might not have all the information you need in order to do that. And look, you're already doing the height line. So you're just doing one extra calculation if you do the rectangle in the middle. But still another way to look at it. I still say the formula came from thinking about we have two triangles, right? So base times height, or half times height is just like triangles, but two different bases from the top to the bottom. Okay, let's see this in action. Ooh, we have a perpendicular line. 90 degrees, right? Yay, we already have our height. We don't need to imagine it. So 1, 2, 3, 4. Goodness, what is with my 4, huh? And yes, I should have done a unit. Let's do meters. And we have a base of 1, 2, 3, 4, 5, 6, 7. So that's 7 meters. And we have this base too, 1, 2, 3, 4. And that is all we need, right? We need the two bases in the height, and we're going to do half of them because it makes two triangles. So when we calculate this, let's plug them in to our formula. Half times height times, well, don't forget your parentheses, base 1 plus base 2. What was my height? It was 4. What are my bases? Oh my goodness, don't forget your half. And base is, and again, it doesn't matter which one's which. You could say 7 and then 4, 4 and then 7. You're adding them either way. Doing that first, 11 times 4 times half. Well, I don't, either way, it doesn't matter which one you do, but I'm still going with the smaller. 2 times 11 equals 22. So the area for this is 22 meters squared. I didn't have my square here. So this is a trapezoid that has a right angle, so you don't need any imaginary height lines. So that's why we did that example. Another one that could be weird sometimes is instead of cutting it in the middle, they might still come out on the side here. And mainly, especially with this one, because doesn't it look like both of those triangles are equal? So some people will see that it's like taking this one off and putting it over here. Makes like a rectangle, doesn't it? But not every trapezoid will look that way. So when we have this height line, 1, 2, 3, 4, this is just comical now. Let's call this inches. And then our bases, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inches, let's say. And this base, 1, 2, 3, 4, 5, 6 inches. All right, let's plug in our formula. So we have half times height times base 1 plus base 2. This time I put that multiplication sign there for you. So we have a half. Our height is 4, like always. And then our base is 10 and a 6. So solving that, I'm going to get 60. Drop down my 4. Drop down my half. I don't know. What would you do first? Would you do 4 times 60? And you could do half of 60 too. Make that easier. This is still pretty easy mental math. We're working with a multiple of 10. So I'll still just stick with what I've been doing. And did half of 4. So then 2 times 6 I know is 12, multiple of 10, so it's 120. And because we're talking about inches, inches squared. How'd you do with that formula? More steps, right? More to remember. So let's look at all the different ways we might see it. Area equals half times height. Let's write out the words. Times base 1 plus, don't multiply them, base 2. Okay, so A equals half, like we've been doing, half times height times base 1 plus base 2. So that one looks familiar, but also just wanting to show that you don't need some of those operation symbols. You could just have a half and a height, and then you still need the parentheses, base 1 plus, you still need the addition sign. You can't have those next to each other without it. That only works for multiplying. Okay? All right. Let's check out the back. I think these images are really good. So you can see that if you have a trapezoid, like I was showing you with my pen, you can cut them in half and you have 2 triangles. So because one of the triangles has a different base possibly, and then this triangle has a different base, you're going to have to include both of those. So what this is showing is like, okay, what I would have to like find this triangle and I would have to find this triangle and then put them together. So that's how we're getting our formula of let's put those bases together. This might this might be a little like, ooh, what is happening here? But it's really just splitting up, like you are doing 2 different triangles, and since you are going to be adding them, you could separate that half in the height and then add the bases together first. Okay, with just like the formulas we did on the front. And another way of looking at all these different types of trapezoids already cut for you, like I was showing with my pen. So see how they would have 2 different triangles, 2 different triangles, 2 different triangles, and that's why the formula works. Okay, so here's a model for you. And you're going to see a lot of these, and you would have practiced possibly these, but we didn't show them when we were practicing together with triangles and parallelograms of what if I give you the area, 12. Whole thing's 12. And you have to figure out a missing dimension, like the base, right? So that's when I say plug into the formula. This is a bit for me, so I'm going to rewrite it. It's too much smushed together. So half times the base we don't know, but we know the height is 6. See, because it makes that 90 degree. So, we know the area. Goodness. That's a thing to also plug in then. They said the area is 12. So if we can do half of 6 and we get 3. So then we still have the base. And we can do the inverse operation, or in our heads, we can think about what times 3 equals 12. And so then that would be, or you could divide 12 by 3, right? And that's what they're showing here. And so then that means B would equal 4. So you might have to find a different dimension. Careful though. So this one would be, if they were talking about inches, it's not squared then because they were just wanting the base, right? And they could also have the missing height. Now, with this one though, I just want the area. Let's practice this one together. So take a second, analyze this trapezoid, think about your formula. You can even record it down. What's the height? What's the base? One and the other base. Which one is which? Hopefully you're an expert at this by now, because the concept is still the same. So we still have a half. Which one did you say the height? 9. Bases? Yep. 15 and 5. We couldn't find the perimeter of this one without this dimension, right? All right, so adding these together first, order of operations, you get 20. All right, now this is what I'm talking about. I don't want to do half of 9 because it doesn't go in as nicely. Could definitely do half of 9, but then I'm working with the decimal or a fraction. So I'm going to do half of 20. Half of 20 is 10, and a nice easy 10 times 9 is 90. 90 centimeters. What? Yes, squared. All right, you are now expert in all things area for our polygons of triangles, parallelograms, and trapezoids. Let's get to practicing.